Part 3 of Dalton's Playhouse, Diamond and Charcoal. Lavoisier observed that the gas produced by its reaction condensed into a clear liquid, which he later realized was water. This observation prompted him to change the name of phlogiston to hydrogen, from the Greek words that mean water maker. So here we'll click Next to carry out an important 18th century experiment. So here we have our apparatus, and we are going to be using magnifying glass to concentrate light energy to heat this diamond here. And as a result of the heating of this diamond, we are going to observe a few changes, such that oxygen consumed and gas produced. And so we have diamond in the form of carbon, right? Or sorry, carbon in the form of diamond, rather. And so we're going to start with 12.01 grams of carbon, right, in the form of diamond, and we have 32.00 grams of oxygen available. We'll see if it actually is consumed, and then we're going to measure the in both grams and liters the amount of gas produced. So let's and then we have a fairly extensive data table over on part 3, your handout for you to fill out. We have all of these things. We have, again, starting with diamond and then charcoal. We'll talk about the difference between diamond and charcoal in class just a little bit. But we are starting with 12.01 grams of our carbon, okay, not 0.20 grams or 0.40 grams. So let's go and start it. Here comes the heat. We are reacting with the diamond. You can see that the amount of oxygen is going down. So oxygen is clearly being consumed. And you can see all these little bubbles of gas being produced. And so we're producing some sort of gas. Okay, and we see that we started with 12.01 grams of carbon. We ended up with nothing. Right? So we burned up the entire diamond. And we started with 32 grams of oxygen, which is 22.4 liters of oxygen gas, and we used all of it. It's all gone. All right, so you can see that we have 0 grams remaining, which is to say we have 0 liters remaining. And gas produced, we started with no grams, no volume, and we produced 44.01 grams, which is 22.4 liters. Watch it one more time. Here comes the heat energy. We're reacting the diamond. The oxygen is being consumed, and the gas is being produced. All right. So, number 1, if no oxygen were present, no oxygen was present. Okay, so we have this large container of oxygen. If this was not present, if we did not provide any oxygen for this reaction, okay, that's the scenario. In the animation, we clearly do provide oxygen, but if we didn't, what do you think would happen to the diamond? The diamond would disintegrate just as it does in the presence of oxygen. The diamond would not change as it could not undergo the chemical reaction, or the diamond would grow in size as the sunlight were absorbed by its surface. Well, it turns out that nothing would happen. The diamond would not change, because in order to observe this change, to have this chemical reaction be carried out, we have to have the presence of oxygen, because oxygen is involved in the reaction. If there is no oxygen, the reaction cannot progress. Number 2, diamonds are made of carbon. Which of the following might be the gas produced when the diamond is heated? So again, remember, diamond's pure carbon, right? What makes diamond different from charcoal isn't what it's made of. They're both made of pure carbon. It's how the carbon atoms are arranged with regard to one another. So they're pure carbon sources. There's nothing but carbon. And then in this tube right here, it's just oxygen, pure oxygen. And so we see 2 options in which we have things other than carbon and oxygen. And so A and B are going to clearly be the incorrect response, because we can only generate things, we can only produce things that are made of what our reactants are made of, carbon and oxygen. Number 3. How did the mass of gas produced compare to the mass of the reactants that were consumed? Now again, we started with 12.01 grams of carbon. We started with 32.0 grams of oxygen. Add those together, you actually get the total mass of the gas produced, the exact same. So the mass of the gas formed equaled the total mass of the reactants consumed. So for our free response, how did the mass of the gas formed compare if you used the same amount of diamond and carbon? If you were to use the same amount of diamond and the same amount of charcoal, you'd get the same mass of gas. It'd be the same because it's your carbon source. It's your carbon source.